Oh, jeez.
Hey Miranda,
Mhm.
¿hablas español?
Sí.
Okay, porque vi su apellido y no sabía, y no sé, no sabía qué pasar
Oh,
si
sí.
eres hispana.
Oh, sí.
¿De dónde eres?
De aquí, de Phoenix.
Phoenix. Sweet deal.
Ajá.
Hi, Kaylee.
Hey.
There she is.
All right. Here we go. Ah. Okay, so do you guys want to just jump in, or what do you guys think?
Probably
Did you?
been right?
Well, did we all do Did we practice the questions that were on the review?
Yeah.
Well,
I mean, I
yeah.
Yeah, I did too.
Okay, I had some questions,
okay.
but I mean, if they're all on the quiz, then we could just talk about them while we take it or something.
Yeah, that's what I understood. Like the quiz we're about to
Yeah.
take is basically these questions, right? Okay.
Right. That's what I
And this
think.
one's not timed, right?
No. I don't think so, no.
Okay.
I wouldn't think so.
Okay.
Okay.
So would you rather just do that? Just open up the quiz and then talk about them?
That's fine with me, 'cause as long as you all know that I don't know some of the answers. So.
Yeah, I don't either.
Yeah.
The last couple, like the last 10, I'm like, yeah, I don't know.
Yeah.
Okay.
I
We can
skipped
figure
it.
them out together.
Okay.
So we're gonna dive in.
Yeah.
Yep.
All right.
Is it? Wait a minute. Okay.
Yeah, it looks like the review.
Okay. Let's do this.
Okay.
Okay.
So, which of the following variables are categorical? The number of animals in a zoo, randomly selected brand of toothpaste, age and years of randomly selected vehicle. So that one,
Would be age and rent. Well, I would say age
Toothpaste.
because you can't really just.
Oh, is
Age.
it?
From it.
Age. Yeah. Well, wait a minute.
you can count, can't you? Or
But is age a group? Like, it's not a number, is it? Is it more like a group?
It's like
It's
the
a
way-
category.
yeah,
It's not
and
numerical.
you can't like add or subtract whatever you want into an age because of the ages.
Right. So it's just B.
Well, it should be C as well, but then that doesn't make sense
Oh,
because the bottom says A and B,
right.
but it should be B and C.
Right.
so we're just saying age, right?
I would guess.
Wait, why not randomly selected brand of toothpaste?
That's what I kind of thought too. Because on
That's
the
categorical.
on the sample homework it had, yeah, I chose toothpaste also.
Let's go with toothpaste.
Yeah.
But is it number of? Okay, no. Toothpaste sounds good.
Okay, that's the most categorical out of all of them.
Yeah.
I think so. Yeah.
Yeah. I can read the next one.
Go for it.
The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of the following statements are true? 100 is a parameter, 112 is a parameter, 100 is a statistic, 112 is a statistic.
112 is a statistic.
Right.
Yeah.
So
And
then 100 is a
And then
parameter.
like 100 would be the parameter.
yeah, I'm pretty sure. Yeah.
Yeah, because it says a statistic is an estimate of parameter obtained from a sample. And then
Right.
a parameter is a true but usually unknown number that describes a population. So if they found the mean,
That describes the population.
yeah.
Okay.
Okay.
Okay,
Yeah, you go for it.
I'll go for it. Gotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes?
I put stratified. Stratified?
Would it be cluster?
No, because I
I
think
was-
cluster is when you just take all the ones from the same group. Would you want to do that?
Yeah, you wouldn't want to do that, I don't think, because a cluster, that would just be like just the extremely high property values.
Right.
So probably stratified.
Because that one's the one where you have different
Oh,
groups.
okay.
Take
Okay, I
information,
see. I
right?
see what you. Okay, I see what.
I mean, are we all agreeing on that though? I don't want to go on.
Yeah.
That's what I chose.
Because it's groups of similar items, right?
Yeah,
Yeah.
yeah. I didn't think about that. I was just thinking of like the different numbers.
Makes
that we're
sense.
talking about.
Okay. I'll do 6.
Okay.
When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? That's a cluster, isn't it?
Yeah.
Yeah.
Okay.
Okay, number 7.
At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Simple random.
Yeah, simple
Yeah.
random.
Yeah.
Alright. 8. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
Stratified again.
Stratified.
That's what I thought too.
Okay. That makes sense.
Oh, do we need to open up our SPSS thing, or did you guys already do that?
Oh, I
What?
haven't done. Do we need to?
What if we just have it on our like written down, like I did this problem already?
Oh, then yeah.
Does that work?
Yeah.
Yeah. Okay, so Rose taken of purchases at a crossroads, open the data file. And use this data to. Okay. Oh, okay. Yeah.
I can't get to this stuff because my hard drive died on me, and I guess I can't reinstall it unless I have to figure it out.
Oh, that would be
Oh, you
tough.
better do that before the test.
I should get it fixed. I think I just have to upgrade my computer again, and hopefully that'll work. And if not, then I'll just go on campus and take it or something.
There you go.
That'll work. I wrote it down. Did I write it down, though? That's the question.
So what I have for that one is the mean is 4.771. So if you see that, it jumps out at you. That's what I got.
Okay.
Can you guys still see me?
No.
Okay, hold on. How about now?
I can, yeah.
Okay, that was weird. The computer just had a freak out. I really hope it doesn't just shut down on me.
No.
Oh.
It's still
Oh, it's because it was okay. Hopefully it'll be. I'm just gonna do it again because I can't remember where I wrote it down. I did this on Saturday.
Okay, yeah, I have mine right in front of me, so. I have the numbers, but if you guys want to confirm with me, that would be great.
Yeah, that's why I'm opening it up right now to redo it and just make sure.
Okay.
I mean, I trust you and everything.
I would not. Today I was having a rough day with stuff.
Okay. Calculate the mean of these datas. What the heck? There it is. Whew. Okay. Hold on, it's loading.
You know, that thing is so ugly.
What thing is so ugly?
This program.
I was like, what?
No, this program. It's like, oh my god, please just load.
Uh-huh.
Okay. Alright, I got the mean to be 4.77. So what you got?
Sounds good.
That's what I got. Let me go back.
Oh, but it's 3 decimal places. But
It's 4.771.
yeah, there we go.
Yeah.
Okay, using software, calculate the standard deviation. I got 1.912.
Yep, that's what I got.
1.912.
Yeah.
Yeah.
I created a histogram. Yes.
Yay!
I did on Saturday.
Just so you guys don't think I'm like mooching off of you guys or anything, but I'll make sure to like make sure that this program works for me, and I'll just go through it and just plug all this stuff in too.
Yeah.
Yeah.
Okay, am I reading the next one?
Go for it.
Okay. Jessica Meir and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals, named Bodil, Roberta, Larry, and Her. The seal's body temperature at the start of the dive was calculated to be these things. Complete the following table and answer questions 12 through 15 below. So I have those as well.
Yeah.
If you guys just want to find them, then we can compare or whatever.
Yeah.
What does it want? A? Oh, yeah, just A and B.
Is that the same order as the homework?
Should
Yes, only it's question 11 and 12 instead of 12 and 13.
Okay.
Yeah. Well,
What
not
did
the
you
homework.
say the average was?
The what?
Never mind.
So
Okay.
the mean was 38.08? Is that what you got?
07,
Check.
same. That's what I got.
Yeah. Wait, yeah. 38.075, yeah.
So A is negative 0.170? I think. Is that what
That's
you got?
not what I got.
I got negative 0.16.
Yeah, that's
Like,
what
what-
I got.
Would she
I
dock us
think
if
they're
like if
rounded.
would she dock us if like our numbers are just like 0.01 off or something like that?
Yeah, probably, because I think it automatically calculates your score from, like, exact numbers.
But if you talked to her and you were like, hey, I was off by 0.0001, you know? Or like something like that, and you'd be like, dude, I think we can talk about this.
Okay, wait. So for A, you guys got negative 1.6. Negative
Five.
0.165, right?
Yeah.
Okay,
Yeah.
good.
6.5.
Okay, and then B. I wish I remembered where I wrote this down. That is sucky.
B is 0.6.
7.2.
I don't know. See, now my numbers
For
are all.
13,
I got 0.67.
I got
Yeah.
0.681.
I got
Let me
8.
try this one again. Make sure I didn't give up.
What did you get for the deviation from the mean?
Ooh, I don't think I wrote that down.
Okay.
I got, from the deviation of the mean, negative 0.825.
Okay.
Yeah, that's what I got for Roberta.
Right.
So that'd be B. Yeah.
Okay, so the answer is 0.681 then.
Yeah, that's what I got.
Oh, what number? Are we still on 13?
Yeah,
that
that's
was
13.
You guys came up with 0.672? Because that's what I got.
681.
681?
Yeah.
Huh. So is it 37.25 minus 38.07?
Right.
Square root?
Squared.
Yeah. And that's what.
Yeah.
How are you guys getting 81? Because I keep getting 72.
That's weird.
Yeah, it is.
You might check your parentheses because sometimes if you do a square root, it might grab onto something or like, I don't know. Just make sure in the right order.
Because you're getting negative 0.825, right? For the difference.
Yeah.
That's weird.
Yeah.
Divide square root. Oh, okay. It's just I didn't put the fifth decimal, the third decimal place in. Okay.
There you go.
Okay.
Okay. So what quantity is equal to the sum of the numbers in the squared deviation column?
I was not sure on this one. That was one that I was like, whoa.
Yeah, I didn't remember.
Yeah, this one.
I thought variance?
I think so. Hold on a second.
That's what I put, but I don't know if it's right.
Let me see. Usually they have...
Some of the numbers.
And I didn't see that in the lesson review either.
Yeah, no, I didn't.
Well,
I'll have to go back and look at all our old
The
lessons.
sum of the numbers in the squared deviations column.
okay, let's see.
Because I know the variance is like the square root of the standard deviation. And the standard deviation is the sum of the sum of the deviation, the square root. Yeah, sorry.
Hello.
Oh, it should be. I think it's standard deviation because it's the squared deviation divided by n minus 1. That makes sense.
I'm not sure. Wait. So you're saying it would be the variance?
No.
That's what I. What?
Hold on. Equal the sum of the numbers. Would it be the variance? No.
I don't know. What is it?
Because I don't think it's the standard deviation. Because the standard deviation is like 8 or something. Or like, I don't know. Well, maybe. Wait, I don't know.
Or I think I'm getting confused.
Wait.
Hold on.
Okay, I think I found it. Hold on.
Because I know the variance is the square root of the sum of the what you get for your. The variance is the square root of the standard deviation. There we go.
The square root.
I'm having a hard time talking today.
You were totally good. Let's see.
Do you think this is like in the very first lesson?
Wait a minute. It might be the standard deviation because just by inference, the next question is what is the standard deviation of these temperatures? And the only way that would be is if you like added those up, right? Yeah, maybe not.
Okay, wait. Sorry, I'm reading the. I think I found it. Maybe. Yeah, so the standard deviation is going to be the sum of them squared, sum squared, and then you square root it. So.
That's not. It's not a standard deviation, right? Wait,
so it's none of these?
Hold on. I'm trying to.
Yeah,
No, sum variance equals that squared. So it is variance.
oh, good.
Oh, okay. Yay!
I think so. I mean, that's what I'm reading. I'm in lesson 3, lesson 4.
Oh,
Oh, yeah, I think it's the variance. I was getting goofed up.
But this is about probability, so I think it's variance.
It's in lesson 3.
Okay.
And then so like in order to find the standard deviation, we just add them together and take the square root? Is that what it said?
It said, let me see. So it said standard deviation is equal to. Okay, hold on.
is it the mean of those divided by the n thing?
That's how you figure out the variance.
I'll be right back.
Okay, let me share my screen with you guys
Okay.
to show you what I'm looking at. Hold on.
This question is
Yeah, this is where I got tripped up.
Wonderful. Perfect.
because what makes me really nervous about these problems is that if you goof up just even a tiny bit, it throws off your whole.
Yeah, unfortunately. Yeah.
Okay, so here's what I'm looking at. This is
I'm Miranda. What's your name again? Jennifer. I see you guys
it
at
says
school.
the sum and then variance equals
Absolutely. Thank you.
Oh,
Bye.
whoa. What?
so.
Okay.
But this says, I mean that's what we did, right? X minus the mean squared,
Yeah.
and then the probability. But
So variance, sum of the variance.
times the probability.
What is the probability?
Hold on, let me go back a lesson. Let's see.
Are we still doing number 15?
Yeah, we're still on the same
Okay.
one.
I had to step out for a second.
Yeah.
Oh, jeez. What am I doing here? Stop that. Wrong one. Okay. Can you guys still see my screen? I don't even know.
Yeah.
Okay. So let's see. Where's it at? Here it says standard deviation and variance.
Oh, yeah.
I mean, we could plug it into the program, but oh,
How did they calculate that? What, it's S? Is that what they're calling?
Calculating the standard deviation by hand.
okay, that's what this one is. So, come on.
What was that chart that's
This
up
one?
above? Oh, okay, that's not important.
No, it's just giving you data. So it gives us the mean. There's gotta be. Okay, deviation from the mean equals
Okay.
7.
We're getting close.
You can feel it. Ugh.
Oh, hey guys,
Yeah?
I gotta take off.
Oh.
I thought my training was at 10, but I just got a text from my friend that it was actually at 9, so I gotta bounce.
Okay.
Oh,
Sorry, guys.
can you save your thing for later?
I see the option, so I'm gonna have to do it later.
Okay.
All right, sorry guys.
Good luck.
Alright.
If you have questions, I guess text us or.
All right, sure. Well, thanks guys.
Okay,
Yes,
see you. Have fun.
See ya.
Bye.
Okay. So, okay, there's got to be like a chart here.
Yeah, what was the S? When it had
Okay.
S, what's S? Oh, right there. What's
Standard
that?
deviation.
Equals S
Sample
squared.
variance.
S is the sum squared, which is what we just did, right?
Right.
Or we just
So it-
squared the sum. Wait.
Oh, gee.
Hmm.
So the number you computed in step 5 is called sample. Divide the sum of the squared divisions by n minus 1. What? Okay. Oh. Ha ha ha! Okay.
Oh, there we go.
We found something that looks like we've done. So,
Oh, I don't think they calculated the sum for us.
no, I think that's the next step. There you go.
Okay, so the sum. So
Observation.
I have the sum for us when we're ready. I
Okay.
added it together.
And
And
it's
it's-
actually just those 4 numbers added, right?
Yeah.
Okay.
And I got 1.5341.
Okay.
And that's going to be our standard deviation, right?
No, you have to do another step.
Ugh, okay. We would expect the sum of the squared deviations to be a lot larger than it is now. We would be adding squared deviations. Remember, we are trying to find a measure of the spread of data. Our final measure should not be dependent on sample size. What can we do to make sure? This seems very odd. Okay. So s squared is equal to the sum divided by n minus 1.
I don't think that's the right option, though. There was 3 options, and I think...
Neither of these?
Well, does it say which one is correct? Oh, okay. No, that one must be right, then. Is the first one the wrong one?
Yeah.
Just make sure.
Yes, this is an excellent suggestion. There are good reasons to choose this option. Unfortunately, divided by n to estimate gives too low.
Okay. So option 2 is correct. So what we would want to do is divide the sum by... What do we want to divide the sum by?
Was it? 1, 2, 3, 4.
So
4
3.
minus 1, so 3.
The sum by the number?
Yeah, of
Right.
n minus 1.
So 1.5341 divided by 3?
Yes.
Yeah.
So I got 0.511366666.
Okay, and it says n minus 1 would lead us to the standard deviation. Okay.
So that's the standard deviation?
Yeah, the number, but that gives us a sample variance. Hold on.
Let me check this out.
The sum of the squared deviations is the sum of the values. Sum is equal to, we divide the columns, we get a sample variance. So, take the square root of the sample variance to get the sample standard deviation.
So we just take the square root of 0.51136.
Yes.
The square root of that or the square root of 1.5341?
So s is equal to the square root of the sum of the third column divided by 3,
Okay.
which
So
we
the
found.
square root of that would be, it equals 0.71509. Is that what you got?
Yes.
And that makes sense because if you look at the numbers, they're super close together.
Yeah.
Okay.
All right.
So, where are we? Okay. So 0.7 And 16.
Under certain conditions, the standard deviation can be negative. That's
False.
False, yeah.
because you have to square root it.
Yeah.
There you go.
Okay,
Okay. Should I read it?
go for
In
it.
the same study, the researchers placed thermistors, temperature sensors in the three seals named Chick, Starburst, and Patty near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals named Sir Richard, Jerry, Sammy, Nut, Jonesy, and Butler in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 other seals named Bodle, Roberta, Larry, and Purr in their hepatic sinus. The results from this study are summarized in the table below. Which location resulted in the most consistent temperature measurements from one seal to another?
That'd be extradural, right? Because
Yeah.
That's what I put because the standard deviation is the smallest.
yeah.
Yeah.
Okay. I can define standard deviation in my own words. Yeah. It's the, well, let's try and define it in our own words then, I guess.
Okay. Standard deviation is the distance from the mean in a certain unit.
Yeah. Yeah. I mean, that's what I would say. I'm looking for the exact definition. But
Yeah.
standard deviation is a measure of the spread of the distribution. So.
Oh,
Yeah.
okay.
No, yeah, so that's right. Yeah, it's the distance
Yeah.
from the mean. You're good.
Okay.
Yay!
Is it the distance on both sides, or is it just like the distance?
Yeah,
Both
it's
sides.
both
Okay.
sides. Mm-hmm.
Okay.
So the number of hours students spent studying for an exam are recorded. The data are represented in the box plot. Use the box plot to answer 19 and 20. So the third quartile would be
8.
8?
Yeah.
And then, what percentage of the data lies between 4 hours and 8 hours? Don't include a percent sign. So, because 4 is the first quartile and 8 is the third quartile, that means there are
50%?
yeah, there's
Yeah.
the difference between 25 and 75%, which is 50. So there you go.
Okie doke. Ooh. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52. The values outside of this range are unusual. We will assume 1.59 is the value of mean equals 2 standard deviation, and mean, minus 2 and plus 2 standard deviation is equal to 2.52. It is reasonable to assume the measured nitrate concentration is normally distributed. So estimate the mean of the nitrate concentration of Rexburg's drinking water.
So when I calculated this, I got the standard deviation to be 0.2325. And so if you multiply that by 2 and subtract that from the top part, which is 2.52, then you would get the mean. Is that what you guys did?
Okay, wait, say that again. Sorry.
So I found the standard deviation first.
Uh-huh.
And then after I found it, I multiplied it times 2 and subtracted it from that max value that it said the mean plus 2 standard deviations is 2.52. So I just subtracted 2 standard deviations in order to get back to the mean. Does that make sense?
Oh, yeah. And what did you get?
And for the standard deviation, I got 0.2325. And I did that because 1.59 minus 2.52 equals negative 0.93, or just 93 really, because it's the distance from the mean. And I divided that by 4 because it's 4 standard deviations total. And that gave me 0.2325.
Mm-hmm.
And then you set it equal to each other? Or like you set that plus 2 standard deviations. You multiplied it by 2.
Yeah, because
That
it's
equals 2.52.
Yeah.
you subtract it from 2.52.
Right. But I mean, like if you were to do an equation, you would say 2.52 equals the mean plus 2 times standard deviation.
Yeah.
And then you subtract it over. Okay, yeah, that makes sense.
Okay.
So the mean that I got is 2.055. And then I just checked my answer by adding back on 2 standard deviations to see if it would fit back onto 2.52, and it did. So.
Did you try it for 1.59?
Yeah, here, let me just double check again. So if I said the mean was 2.055, like I think it is, and I subtract 1 standard deviation, which is 0.2325, and then I subtract another standard deviation, so 0.2325 again, then I got 1.59, yeah.
Okay.
Yeah, that makes sense. I just checked you too. That works.
So the mean is 2.055.
Okay.
And the standard deviation is 0.233.
Because, yeah, it can be right. Okay. So between what two measured nitrate concentrations 68% of the beta value? So then we'd take the mean plus 1 standard deviation, right? Plus or minus 1 standard deviation.
Between 2 measured nitrate concentrations. Yeah, wait, yeah, so you just take the mean and add 1 standard deviation, which is 2.055.
So it's between 1.822 and 2.288.
288, yes.
That's a good way to check.
Yeah.
It's one of the options, so that's good.
Yeah, that's really good.
Oh, yeah. 280.
Okay. What is the value of the mean of the standard normal distribution? Wait, did we already ask for that?
What is the value of the mean of the... No, the normal standard distribution... Wait, hold on. The value of the mean of the standard normal distribution.
Wait, so maybe it's estimate the mean of the measured nitrate concentration in Rexburg's drinking water?
Estimate?
Wait. City of Rexburg...
So would we just say, like, officially...
Oh, wait. So, estimate the mean of the measured nitrate concentrations. The City of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52.
Oh, so we would just guess somewhere in the middle, right?
Yeah. Do it. So the mean of the standard normal distribution would be 2.055. And then for number 21, we just add those two together and divide by 2.
Perfect. Okay. Man, I did it all advanced too early.
Okay, so I got it's 2.055. It's still 2.055.
Yeah.
Oh, wow. All the work, and it was still... what?
That easy.
Okay.
But how is that possible if it's... because it's 0.55. Got it. Okay, never mind. Oh. Okay, so just to make sure we did that right? Because then it says, what is the value of the standard deviation of the standard normal distribution? Wait a minute.
Oh, we have to estimate again? Dang it!
Wait.
Okay, wait. Nitrate concentrations.
Standard deviation of a standard normal distribution.
What is the value of the means of a standard normal distribution? Oh, wait, because the Rexburg questions are only for 21 and 22. Okay, so these are totally separate. So what is the value of the mean of a standard normal distribution? Is it...
What is the value of the mean of a standard normal distribution?
Hold on.
What? How is that? That doesn't make any sense.
Oh, man.
Hold on, let me see if I can...
Is this going to be in one of our lessons
Wait.
we had?
I think it might be applying to number 26. Oh, no. No, I lied. 20, what? 24,
Mean and
25.
standard deviation of the distribution of sample means. It's not the sample mean thing, is it? The mean of a sample mean.
Okay, I'm pulling up the lesson normal distributions. I'm glad we're doing this together. This is going to suck when we take the test. Okay.
Okay.
What is the value of the mean? Is it X?
The value of the mean of this. It doesn't say to round 3 decimal points. It might be X. What is the value of the standard deviation? But how would you get that weird symbol on there?
I have no idea. The z-score is positive, then the observed value lies in... Oh, that's talking about z-scores.
Just like lesson 6 is sample distributions. What's the question again? What is the value of the standard deviation of a standard normal distribution?
Okay. This is a confusing question.
Yeah, it is. How many observations correct? If the parent population is normal, then the sample distribution is...
Maybe we can come back to it.
Yeah, let's come back to that one, I guess.
Is it going to be the same, though? Is it going to be the same as the standard? What's the value of a standard deviation of a standard normal distribution? I don't know. I'm just thinking, is it the same? If it's a standard normal distribution, is it going to be the same? What is the value of the standard deviation? Is it going to still be the same standard deviation?
What is the value of the mean of the standard normal distribution?
Is it still talking about the ones above? Because I think it might be.
I don't think so.
Oh, is this a whole nother thing?
Well, because it says use this information to answer questions 21 and 22.
Oh.
But then 23 says what?
Yeah.
Part of it.
Yeah. I think it might apply to the question still. Of a standard normal distribution.
Yeah, but I feel like if it did, it would say of the standard, of, like, instead of a standard, you know? So
I think, right.
says, huh?
Or keep going, you're good.
No, it just says the mean is the most common. It's computed by adding up the observed data and dividing by the number of observations in the data set. But I don't know.
The applet.
No, that doesn't help at all because the applet won't tell you the mean.
Oh no, it tells you the other thing.
Percent.
That's right, percent.
I think the best we've got is based off of the problem above, because otherwise it's just a hanging question and there's no answer.
Yeah.
But we can come back. I think that'll be good. So we'll just
Okay.
remember 24 and 25.
Yep.
Okay. We'll come back to those too. Okay. So the admission committees for most master businesses programs required a graduate GMAT as part of the application for new students. It's been shown that the scores in the GMAT are normally distributed with a mean of that 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MAACC program of the School of Accounting at BYU is 500, but it is rare for students with the score less than 600 to be admitted. So what is the probability that a randomly selected student will score above 542.3?
So when I did this one, 542.3 is the same as the mean, which means that it's right smack in the middle and there's no standard deviation, which means you can either get above it or below it, so it's a 50-50, so it's 50%.
So would it be 0.5?
Yeah, because that's the nearest tenth.
Yeah. Okay.
Okay, so what is the probability that a randomly selected student will score below 600 on the GMAT? So I have an answer for this one too. And I have answers for the rest of them. I don't know. We'll see if I got them right.
Okay, so for this one, I think what I did was subtracted that from the mean, and then I did.
Yeah.
I'm trying to remember what I did. I found the z-score. That's what it was. Sorry, and then I divided it by the standard deviation.
The z-score?
And then I plugged it in the applet, I think.
Okay, so I did 600 minus the mean divided by the standard deviation, which gets the z-score.
Right.
And so once you have the z-score, you know that the z-score times, what did I do here? The z-score times the mean. No, wait. Oh, once you have the z-score, you plug it into the applet.
Yeah.
Right.
And then you hit all the things to the left of it. And I got 0.684%.
Did you get the z-score of 0.479?
Let me check.
Yeah, that's what I
Yeah.
got.
Okay.
Yep, that's what I got.
Everything to the left of it, right?
Yeah, because it's lower then. So
point-
that means the next question is on the opposite spectrum.
But it was 0.684, right?
Yeah.
Okay. And then, so it'd just be, what is it, 0.7 or point?
0.316 on the next one.
Yeah. Okay.
To the 10th percentile.
Oh, crap, 10th percentile.
So
Okay.
I have that one too.
This one
It's
you
just
just
like-
plugged in, right?
Yeah.
10% at the top, right?
Yeah,
Right.
and then you go to the left instead of the right.
And you got 0.0999.
I actually got a different one for some reason. What happened? I got negative 1.282. Let me double check.
Oh, well, that for the z-score, yeah.
Yeah.
Yeah. And then, but the probability... Oh,
So
wait.
So the z-score you multiply by the standard deviation and then add 542.3.
Oh,
So
Right.
Yeah.
2.8. What was it? Negative 1.282.
Times,
The standard deviation.
which is 120.54.
And then divide by the mean, right?
No, you just add the mean.
Ah, yes.
You add it.
Yeah.
Oh, okay, yeah, I see that.
So 387.7.
768. Yep.
Oh, but it says round to the nearest whole number. So 388.
Oh. Yeah. Oh, why is the whole number? That's weird.
Yeah.
388.
GMAT. And then the 90th percentile, the z-score would be. Ooh.
So I have that one too. Whenever you guys.
Isn't it the same z-score?
It's on the opposite spectrum.
But yeah, so it'd be positive. So it'd be 1.282 though, right?
Yeah. 1.282. Yeah.
So then.
Times 120.54 plus 542.
Oh, what was it? Sorry, what was the mean again?
542.3.
Holy cow! So 696 or 697, I guess, rounded.
Yep, that's what I got.
Okay.
Miranda, is that what you're getting?
No, I haven't finished. I'm not as fast as you guys.
Good.
Okay.
Oh,
What was it again?
by the way, I figured out. Haha! I figured out the two that we missed. We'll come back to that.
Oh, yay.
Okay.
Okay, find the first.
Okay, what was it again?
Uh,
What did you get? 0.996?
for
For number 30?
Yeah. What was it?
No.
we got 697.
Oh. Okay. I'll have to come back to that one. All right.
Well,
What did
we
you
can-
figure out?
We can work on it.
Let's do those other two first.
Okay. Well, let's finish it out and then we can go back to them because that'll be since we're talking about GMAT scores, that'll be better.
Okay.
So find the first quartile of the distribution. Oh crap.
So, same thing. You just go back to the applet and you put 0.25 for the area because that's the first quartile. And then you get the z-score, which is negative 0.674.
Yep.
So that z-score, you multiply again by 120.54 and add 542.3.
542.3, right? Okay.
Yeah.
I got 461.
Yep, that's what I got.
Okay.
Okay.
And then third quartile, I gotta do 75%.
Yeah, so put 0.75 in the area part of the applet. Then you get a z-score of positive 0.674. Then you multiply that by the standard deviation and add the mean.
3. So 624.
Yeah, because it's 623.54.
Yeah.
Are you following along, Miranda?
Yeah, I got that. Yeah.
Okay.
Okay. We're so close. Considering a simple random sample of n equals 15 students taking a GMAT, what is the mean of the distribution of the sample means, according to sample numbers of all such samples? So this one is the, oh crap,
So the mean, because it's a normally distributed graph, is the same mean as before.
Right.
right.
So what is the mean distribution? So Yeah, so it's 542.3.
Oh, because did the GMAT say it was normally distributed?
Yeah.
Okay. Then yeah, so it'd be 542.3.
Okay.
Okay.
Okay, what is the standard deviation of the distribution of sample mean scores for all such samples? So the standard deviation, do you guys remember how to do that?
Yeah, it's the standard divided by root, right?
Right.
Yeah. Yay!
All right, so I got 31.123.
Yep.
Okay.
Miranda,
Hold
did
on.
you get that?
Hold on, I'm still doing my calculator.
Okay.
Oh, crap. 20. Okay, what did we get again for that one?
31.123.
Okay, yes.
Yay!
No.
And 3 witnesses.
All right.
So the probability that the sample mean score will be greater than 600, I got 0.015.
Hold on, which problem is that?
35.
I might have done it wrong.
35.
Because you take 600 minus 542.3
Mm-hmm.
and then divide that by 120 point, what is it, 54?
Yeah.
Divided by the square root of 15.
I got a different answer.
I got 1.854.
Oh, that's the z-score. So you need to punch that into the applet.
Ah, that's why. Okay. So, 1.8539. Okay, so the probability that this, what is it, less than? Oh, greater than.
Greater than.
Okay, so 0.0319.
Yeah, that's what I got, but since it says 3 decimal places, I did 0.032.
Okay. Yes.
Okay.
Yay.
Yay!
Well, then
Alright.
to answer the questions, what the value of the mean of a standard normal distribution is, it says that a normal distribution with a mean of 0 and a standard deviation of 1 is called a standard normal distribution.
Whoa!
So if the mean is 0 and a standard deviation is 1,
That's so weird. Where did that come from?
Google. An online
No way!
yeah.
I
It's an online stat book, so it's got to be pretty close.
If it's wrong, we'll go have a chat with her.
Yeah, and it's literally word for word. It says a normal distribution with a mean of 0 and standard deviation is 1 is called a standard normal distribution.
Wow. Okay.
So the mean is 1?
Mean is 0, standard normal distribution is 1.
Okay, mean is 0.
Yeah.
So 24 is 0, 25 1.
Right.
Yep.
Oh my goodness.
I think we did it.
Should we review just in case? Make sure we got everything matching?
Okay.
Because it's such a
Probably.
big test or big meaning.
Yeah.
So 3 was a randomly selected brand of toothpaste.
Yes.
Yes.
4 was 100 is a parameter and 112 is a statistic. Parameter, wow.
Right. It's late.
5 was stratified sample.
Yeah.
6, cluster.
Yep.
7, simple random sample.
Yes.
8, stratified random sample.
Right.
Yep.
9, 4.771.
Yes.
Mhm.
10, 1.912.
Yes.
11 was true.
Yay.
12, negative 0.165.
Yes.
Okay, 0.681. There we go.
Mm-hmm.
14 was the variance.
Mm-hmm.
Mm-hmm.
15, 0.715.
Right.
16, false.
Mm-hmm.
17, extradural.
Yes.
18, true. 19, 8.
Mm-hmm.
Uh-huh.
20, 50.
Yep.
21, 2.055.
Mm-hmm.
Yes.
22.233.
Yes.
23 was 1.822 to 2.288.
Yeah.
24, 0. 25, 1.
Mm-hmm.
26.5. 27.684.
Yeah.
Okay, 28.316.
Mm-hmm.
29 is 388.
Mm-hmm.
30 is 697.
Yeah.
31, 461.
Yeah.
32, 624. 33, 542.3.
Wait, for 32, was it 624?
Yeah, I have 624.
Okay,
Yeah.
perfect.
Okay. And then 33, 542.3.
Mm-hmm.
34 is 31.123.
Mm-hmm.
Yes.
And then 35 is 0.032.
Yay.
Yoo-hoo!
Oh, we missed one. Just one, though. Oh! Oh, man!
Aw, what did we miss?
We missed the stupid variance question.
Oh, man. None of these.
We almost got that one.
No. Dang
We
it.
talked
I
about that.
We did. Darn
should
it.
give it that one because we talked about it.
What is it then? Is there a name for that column?
I guess not. I guess variance only has to do with probability. It must be then.
Right.
All right.
Lame.
Okay. Well, 97. I'll take it.
Yeah, that's good. Awesome.
Good luck, guys, on the exam.
Thanks.
All right.
You too.
Okay, we'll talk to you later. I'll post the video and stuff.
Okay.
Okay, thanks. Bye.
Bye.
Bye. Have a good night.